6 kilometers.
Yep. There we go. Let's do that. How about this?
22 kilometers.
That's it. That's all right. It's gonna be fine. How about this one?
$16 kilometers.
At 12:30. I think you're right. I thought it was a different one. Oops. 1 second. Move that there. 16. Grand. Okay, velocity time graph. How about this?
Uh, 20 meters per second to A.
You'll be fine for the rest of those. How about this?
She opens her parachute at 2,000 meters.
Yeah. Grand. All right. How about this one?
Uh, 5 kilometers.
Well done. Okay, how about this?
Thirty-five and a half seconds.
I think it's just 35 seconds.
All right.
That's my guess. All right. How about this one?
Is it 5:45?
Yep. Because it's halfway between 5:30 and 6. Yep. Okay, how about this?
Half an hour.
Yep. And so, how many minutes?
30.
That's it. Let's see. This one. It's the same idea. This one. It's the same idea. Let's give this a go.
Is it 18?
Well done. Okay, how about this?
Container P is empty first.
You must explain your answer.
Because it reaches 0 liters at 40, whereas Q reaches 0 liters at 50.
Yep. Your answer's perfect. It just takes me a long time to write. Okay, let's try this one.
So how would I complete the travel graph?
At 5 p.m., Simon stopped for 30 minutes.
So we'll go in a straight line from 5 until 5:30.
Yeah. Looks like it's there. Okay.
And then it will go a straight line from 5:30 to 7.
Hold on. That's it. And that's what it should look like. And it does. 7 p.m. Half an hour. Okay. How about this?
Okay, so it'll be in a straight line from 5 to 6:30. And then in a straight line from 6:30 to 8:30.
6:30 down to 8:30. Looks good. Let me just see. Yep, fine. This one looks about the same. Yep. Okay, how about this?
Would it be 7.5 miles?
How do you find distance?
Um, distance is time times speed.
Yep.
Uh, mm, 120
Well done.
miles.
Yep. So it's 30 miles per hour, like 30 miles every hour, 4 hours. So that's 120 miles. Okay. How about this one?
Stops in so 15 minutes. So it'll be a straight line from 30 to 45. Mm.
The trick is to find the time. In all the previous questions, you knew the time 30 minutes, an hour and a half. Earlier, you said distance is time times speed. What is time?
Time is all time is distance times speed.
No.
No, distance divided by speed.
Yeah. Divide both sides. Distance divided by speed.
So it's half an hour.
Yep.
So I'll go from 45 to 75.
Well done. Great. So the previous ones, they gave you the time. You know, it takes them an hour to get home, all that. This time you had to work it out for yourself. Let's see this one. Yep. How about this?
Alright, so it'll be a straight line from 2:30 to 3:30.
Mm-hmm.
go from 3:30 to 5.
I think so. 45 over 30. By 5 hours. Give this a go. Okay, how about this?
What would the gradient be?
Gradient is change in y over change in x.
Change in y over change in x.
So like, how much does
400 divided by 10.
Yep.
Oh, 40.
So that one is, that is 40. Okay, how about this?
V2.
Yep. Okay. Okay, how about this one?
Oh, 4. Oh. How would you do this?
So this here,
Mm-hmm.
this 40, that was distance divided by, well, that in this case it's miles per gallon. This one was distance time graph, and so the gradient gave you the speed. This was miles per minute. Maybe I need to, which of these two trains is traveling faster, A or B?
A is faster.
Yep, has a greater gradient. And so which part of the journey is Kirsty skating at her fastest?
Fastest speed was. How would you write that?
What do you mean?
Well, the fastest speed was from a 0 to 75.
Yep. And so what speed was she going?
Not sure.
Distance divided by time.
16.
That's it. And what's the unit?
Uh, meters per second.
That's it. Meters per second. Okay. Yeah. So then how about this one?
Uh, is it 60 kilometers per hour?
60 is it?
Yeah.
Kilometers per hour. Seems good. Yep. Let's see. All right.
Would it be 54 kilometers per hour?
And did you do 0.9 times 60, was it?
Yeah.
Yep. So that is 54 kilometers per hour. Yep, grand. We did this one earlier. It's okay. Which one is traveling faster? Okay, how about this?
Uh, is 18 meters per second.
Yep. Between which two times?
Uh, the first one.
So 0 to 20 seconds. Give a reason for your answer.
Because covers more distance in the time, in short time.
That's true. How did you know it would be the first part of the journey, though, just by looking at the graph?
It's more horizontal.
More vertical?
Vertical, yeah.
I'll just say steepest gradient.
Alright.
So it's like the steepest part. Here it's like kind of a bit more gently sloping, and then here it's not sloping at all. 0 to 20 seconds. Gradient is greatest, something like that. 18. Great. Okay, how about this one?
Uh, it increases the fastest in between month 1 and 3.
And they kind of phrase it strangely. Let's say what 1 month was it at the steepest? What 1 month period was the fastest growth?
Oh, between 1, 2.
Yeah. So that's what they intended to ask. Like between which 2 months? Between month 1 and month 2. That's what they meant. Month 1 and 2, steepest gradient. Let's see. Exam question. He drove at 66. She drove at this graph. Who was faster? I think you'd be alright. Just get the gradient for the thing. This one has a little more to it. I'll give it a go. Nah, you know what? It's not really. It's alright. It's alright. Maybe I should, but. Okay, any idea what this is about?
No.
So basically for this, there was like part A that we previously did, and the answer was 1.4. What does that represent? What would be the unit for the 1.4 gradient?
Minutes per or kilometers per minute.
Yeah, and so something like the lorry's speed is 1.4 kilometers per minute. So that's the practical interpretation. So if someone says the gradient of this line is 1.4, the practical interpretation is that it means 1.4 kilometers per minute. Lorry travels 1.4 kilometers each minute. Okay, how about this?
The miles per gallons of petrol used is 40.
Yep. So the car gets 40 miles per gallon. Distance per gallon, miles per gallon. Okay. Let's just jump in. How about this one?
Uh, 1 meter per second.
That's its velocity at 5 seconds. We want its acceleration. So previously we were doing distance time graphs. The gradient of the line gives you velocity. Velocity time graph, the gradient gives you acceleration.
Oh, right.
So at what rate is its
So it would
rate?
be 5.
Other way around?
Oh, 0.2.
Yeah, 1 over 5 instead of 5 over 1. Yeah, and what is the unit?
Meters per second.
It's meters per second, and they often write it as meters per second squared. Basically, it means after 1 second, the velocity is 0.2. After 2 seconds, 0.4, 3 seconds, 0.6, and so on, until 5 seconds, 1.0. And so that's the rate at which the velocity is increasing. So previously we were looking at distance time, now it's velocity time. Okay, let's try this one.
Gavin's maximum velocity is 1.6 meters per second.
Yep. And B.
His acceleration for the first part would be not sure.
How did you get acceleration for the first part of the journey here?
You find the gradient of that bit.
Yep.
$9.16.
And what was the working out?
That did 1.1 divided by 120.
And that was really was it 9.16 times 10 to the minus 3 or something like that?
Yeah.
What was it? 9.16 times 10 to the minus
9.1666666667 times 10 to minus 3.
So 10 to the minus 3, 3 zeros, and then I'll just write 917. And then decimal point goes there. Meters per second squared. And that's quite common. What was that as a fraction?
11 over 1,000.
Okay. That's quite common. That
11 over 1,200.
And what we saw in the previous one, the acceleration was 0.2, and that's because it's squared, and so that would make the velocity increase very quickly, so it tends to be very small. Okay. How about this?
I'm not sure.
What will happen to, or if you want, you can just match it up to the graph. But you see how it is, as time increases, the height of the water. So in the beginning, how will it change at the beginning versus at the end? How quickly the height of the water increases?
The same rate.
Same rate would just be if it was like a vase or something, just like that.
Does the height increase?
So the speed would increase because there's less to fill up. So down here, it takes a long time for the height to increase because there's a lot to fill.
Oh, yeah, I understand. B would best describe.
Yeah, that's the one. As time increases, the height increases at a faster rate. Yeah, so it's accelerating. Okay, match these up, or you can do the worded part A.
Buzz 2 is faster.
And so, which?
It would be A.
Yeah.
And 1 would be B.
Yeah. The water level in vase 1 rises faster first, then slower. The water in vase 2 rises slower first, then faster. Yeah, so it's just kind of why those graphs look the way they do. Okay, you can match these up, or you can answer the questions, whichever you prefer.
All right.
Let's just match them up.
A would be 2.
Yep.
B would be 3, and C would be. I mean, B would be 1.
Yep.
And C would be 3.
BAC. Okay, they did it a different way. Okay, how would you sketch the graphs for these three? How would they be different?
B would be fairly fast. They would all be just a straight diagonal line.
Right.
B would be the fastest, then C, then A.
Yeah. So B, then C, then A, something like that. I think, all right.
I would be A. I mean, 1 would be A. 2 would be D. 3 would be C, and 4 would be B.
Yep. Okay, before we were looking at, so you have this thing filling up with water. This thing's filling up with water, starts off quickly, gets slower. With the previous ones, we would find, if we wanted to find the acceleration, we would find the gradient of the line. The problem is it's not a straight line, it's a curve. And so if we want its rate of change is changing. So in the beginning, it's filling up fast, like its height is increasing quickly, and then at the top, it's increasing slowly. And so all you can do is find the rate at a single point. So if you want to find the rate of increase at 10 seconds, then you just sketch a tangent, or try to draw a tangent as best you can, and find the gradient of that tangent to the curve at that point. And so any idea what the gradient of this tangent is?
Tangent. Be 3.
That would be if it started from 0, 0. It started up at 10.
Oh, it's in. So would it be 2?
Yeah. Unit?
2 centimeters per second.
Well done. And maybe in the beginning, its rate was 3. Maybe at the end, its rate is like 10 or 5 or something. But at that moment, it's filling, like if you had if that's the 10-second point, if you had a vase that was like just a perfect, like, what do you call them? Cuboid or something. Yeah, a cuboid. If it was just straight like that, then that one would be 2 centimeters per second for the entire thing. In this case, it's always changing, so you just draw a tangent at a point, 2 centimeters per second. Okay. How do we do this?
Or you would draw a tangent from 12
Mm-hmm.
to
So just basically a tangent. Where would that go? That doesn't look. No, 12. That's 12. Hang on. So that's 12 there. So it goes through a 4, maybe, is it? 12. That looks okay. So what does that look like?
uh, would it be a 10?
Not sure. So it went up by 80 and it went right. Yeah, you're right. 80 over 8. 10 unit.
10 meters per second.
So speed was 10 meters per second. Right? 10 meters per second. Great. This one. Oh, I need to delete that. Delete tangent. But I think you're good. I think you got it all right. Let's just do exam question. How do we do this?
Yeah, acceleration at T4. Would it be a 5?
Not sure. You would have to sketch a tangent.
Oh, alright. It would be a 2.5.
Yes, because it started up there. Unit?
Meter per second squared.
Yep. They got the unit wrong. 2.5, that's meters per second. Per second. Yeah, they have a little misprint there. Something like that. Okay. And what's this?
Is it 1.5?
I'm not sure. Let's see. How did you get that?
Uh, mm,
Playing from L phone.
Alexa. I don't know what that was.
Hmm.
Oh, no, I didn't do it. Tangent. It's probably wrong. So it's 7.5.
How'd you get
Well, the bit that's coming from is 0.4, and
that? I'm just going to guess at 0.5. That they gave us a kind of easy-ish, you know. So I'll just estimate that at 0.5.
oh, 0.5.
And it is an estimate, they said.
6.
Change in y over change in x. How much did y change by? How much did x change by?
Y changed by 3.
Yeah.
X changed by 1.5.
Yep. Y changed by 3. X changed by 1.5.
2.
Yep. And so 2. Yes. You see how the line is kind of going down on the left side?
Mm-hmm.
So there you have a negative gradient. On the right you have a positive gradient. In the middle for a second it's 0 gradient at the bottom. And so all you can do is sketch it, like draw a tangent and do your best to get the gradient of that tangent. And anything between 1.6 and 2.5. So my guess is it supposed to be 2. Let's see. Average speed is total distance over total time. What is the average speed for the whole journey?
$55.
And how'd you get that? What's working out?
220 divided by 4.
Yeah, sounds good to me. 55 kilometers per hour. Yep, good. What goes average speed for the whole journey? Try B.
$14.6.
So let's say 14 2/3 miles per hour. Okay, they rounded it to 14.7 miles per hour. So you don't always get a nice number. That's for these kind of straight line graphs. Just the average speed for the whole journey. If you want the average speed between two times on a curved graph, you, instead of getting the gradient of a tangent at a single point, you get the gradient of the chord between those two. So any idea how we would do these?
Will it be from 0 to 10?
Okay.
Gradient would be 0.39.
How'd you get that?
39 divided by 10. Oh, 3.9.
That would be up at the top or something. This is 1 square under 30.
Oh, yeah, 2.9.
I think it's 2.9. We go 2.9 meters per second squared. Okay, part A.
Draw a chord from 20 to 30 seconds.
Mm-hmm. So 30 is there.
And the gradient of that would be 0.57.
How'd you get that?
17 divided by 30.
It didn't start at 0, it started at 20.
Oh. Zero point 0.9.
0.9, whatever that is, meters per second squared. Did that work? 0.9 meters per second squared. That's grade 9 right there, allegedly. Let me see. Between points A and B. Alright, let's give this a go.
Alright. So you would draw a gradient thing.
Chord.
Wait, a chord, yeah.
So A and B.
So it would be 0. Wait. 0.4.
I believe it is. There we go. And that's grade 9. Let me see. So in general, if you need the acceleration at a point on a curved graph, tangent at that point, if you need the average between 2 points, you do a chord and you get the gradient of that chord. So one little thing I didn't get to, which was distance. I'll give it a quick go. How do you find the area of a rectangle?
Forgot.
Base times height. How do you
Oh,
find
right.
distance?
Distance is speed times time.
Yeah. And so velocity is a bit like speed. To find the distance, you get the area. So you want the distance from 0 to 12 seconds. How would you get the distance?
You would times it by 15.
Yep.
So 180.
180 meters. What is the distance covered between C and D?
Is it 7,500?
What was working out?
60 times 125.
Yeah. 60 times 125. I thought it was 2,400. What did you say it was? 7.5? 7,500?
Yeah, so
Yeah, meters or 7.5 kilometers. You're right. What is the distance covered for this part? First 5 seconds.
is 5.
It's a triangle.
Oh, it's triangle. What does that mean?
So this would be 5. Triangles.
Oh, 10. 10 then.
Nope. Triangle's half a
Oh,
rectangle.
2.5.
Yeah. Half times base times height. The distance covered between C and D. The only way you can do this is to, same as before, you draw a chord and then you just, as your estimate. Any idea how to find the area of that shape?
Not sure.
It's a trapezium.
Or would you find the area of the triangle and then the rectangle?
You could. A more direct way is that A and B are the two parallel sides and the height is the perpendicular height. So what's A, what's B, what's H?
A is 40. B is 60. H is not sure.
I think it's 125 to 175.
Oh, 50.
Yeah. You can calculate that.
$2,500.
Yeah. And I think it's going to say 2.5 kilometers. And so let's just see. Okay, exam style question. How about this one? This should be the last one.
T6 and T8. So draw a line from 6, a line from 8. So A would be A would be 24. B would be 26.
I think it's 27. I might be wrong.
Yes, 27. And H is 2. 51.
51 is it? So that's 51 meters. Do I have the answer for that one? Okay, so they said it's 50. That's grand. They did that and it's an estimate. Great. So in general, yes, distance is speed times time, area is base times height. So the distance, you do that, you get the area. Chord gives you average rate of change, and then tangent gives you the rate of change at an instant. If it's a straight line graph, you can just get the gradient, but if it's a curve, you have to get it that way. And as you can see, these are all grade 9. Great. So what do you give yourself for that stuff?
I would say a tick.
Great. How was that for you, Jad?
Oh, it was good.
So
Thanks again for the Christmas present.
All right. Any topic in particular for next time?
No, I don't have any in mind.
All right.
Well,
Sorry to keep you
goodbye.
extra.
Have a nice evening.
You too. Take care. Bye bye.